The National Electrical Code, also known as NFPA 70, does not directly cover mobile homes. Mobile homes are considered manufactured housing and have their own specific electrical code requirements. The code that governs the electrical design and installation for mobile homes is NFPA 70, National Electrical Code, Chapter 55. Chapter 55 provides specific rules and requirements for electrical systems in manufactured homes, including wiring methods, circuit protection, equipment installation, grounding, and bonding. The National Manufactured Home Builders Association, or NMHBA, does not have its own separate electrical code. However, the NMHBA does publish guidelines and standards for the construction and installation of mobile homes. These guidelines are typically referenced in the building code requirements of jurisdictions where mobile homes are allowed. Considering the cabin is being built and wired to meet the NMHBA criteria and will be moved onto a state park site, the following codes and requirements apply. Firstly, NFPA 70, National Electrical Code, Chapter 55 for the electrical design and installation. Secondly, guidelines and standards published by the NMHBA for construction and installation. Thirdly, building code requirements of the specific state park. It is recommended to consult with an electrical engineer familiar with the specific requirements of NFPA 70 Chapter 55 and NMHBA guidelines to ensure that the electrical plans for the cabin meet all applicable codes and standards. Some key areas covered in Chapter 55 of the NEC include calculations for feeder and service loads to ensure sufficient capacity for the intended electrical usage. This involves determining the total connected load of all appliances, lighting, and equipment, and applying demand factors as permitted by the code to account for non-simultaneous operation. The NEC provides specific requirements for grounding and bonding to ensure electrical safety and minimize the risk of shock hazards. This includes the use of a grounding electrode system, equipment grounding conductors, and bonding of metal parts to create a low impedance path for fault current. Chapter 55 outlines acceptable wiring methods for use in manufactured homes, such as non-metallic sheath cable, armored cable, and conduit. The selection of wiring methods must comply with the NEC and be suitable for the intended application and environment. Overcurrent protection devices, such as circuit breakers and fuses, are required to protect electrical circuits from overloads and short circuits. The NEC specifies the maximum allowable overcurrent protection for different types of circuits and conductors. Receptacles, switches, and lighting fixtures must be installed in accordance with the NEC and be suitable for use in manufactured homes. This includes requirements for GFCI protection in wet locations and tamper-resistant receptacles in areas accessible to children. The NEC requires that all electrical equipment and appliances used in manufactured homes be listed and labeled by a recognized testing laboratory such as UL or ETL. This ensures that the equipment meets safety standards and is suitable for its intended use. Chapter 55 addresses the unique requirements for electrical connections between different sections of a manufactured home, as well as connections to external power sources. This includes the use of approved connectors and wiring methods to ensure safe and reliable electrical connections. The NMHBA guidelines provide additional recommendations for the construction and installation of manufactured homes, including best practices for electrical systems. These guidelines may cover topics such as wire sizing, circuit layout, and equipment placement to enhance the safety and performance of the electrical system. It is important to coordinate with the local building officials and the state park authorities to determine any specific electrical requirements or restrictions that may apply to the cabin project. They may have additional codes or regulations that must be followed to ensure compliance. In addition to the NEC and NMHBA guidelines, it is also essential to consider the specific environmental conditions at the state park site. Factors such as temperature, humidity, and exposure to the elements may impact the selection of electrical equipment and wiring methods. It is advisable to use electrical components and materials that are rated for outdoor use and are resistant to corrosion and moisture. To ensure the safety and reliability of the electrical system, it is recommended to perform thorough testing and inspection of the wiring and equipment after installation. This includes verifying proper grounding and bonding, checking for any wiring errors or defects, and testing the operation of all electrical devices. By following these guidelines and consulting with qualified professionals, it is possible to create electrical plans that meet all applicable codes and standards for the cabin project. This will help ensure the safety and satisfaction for years to come. To elaborate on the specifics of Chapter 55 of the National Electrical Code, it's important to delve deeper into some of the key requirements. Article 550.10 covers wiring methods specifically permitted for manufactured homes. These include non-metallic sheathed cable, type NM or type NMC, armored cable, type AC, and electrical metallic tubing type N. However, the code also stipulates conditions for using each of these. For instance, when using non-metallic sheathed cable, it must be protected from physical damage where necessary, and properly secured to the framing. Article 550.11 focuses on grounding. This section is extremely crucial because proper grounding ensures safety and reduces the risk of electrical shock. The chassis of the manufactured home must be grounded, and the grounding conductor must be connected to a grounding electrode. This electrode could be a ground rod, a ground plate, or other approved means, ensuring a low impedance path to ground. Bonding is another critical aspect. Article 550.16 requires that all metal parts that are likely to become energized be bonded together into the grounding system. This includes metal siding, metal water pipes, and metal appliance housings. The purpose of bonding is to create an equipotential plane, minimizing voltage differences and preventing shock hazards. Overcurrent protection is detailed in Article 550.12. Each circuit must be protected by a circuit breaker or fuse. The size of the overcurrent device must be appropriate for the ampacity of the conductors it protects. In addition, ground fault circuit interrupter, or GFCI, protection is required for receptacles in certain locations such as bathrooms, kitchens, and outdoors. This is essential for preventing electrical shock in wet or damp environments. Article 550.13 discusses the requirements for receptacles and lighting fixtures. Receptacles must be of the grounding type, and they must be securely mounted. Lighting fixtures must be suitable for their intended use and location. For example, outdoor lighting fixtures must be weather resistant. Article 550.15 covers appliance circuits. Major appliances, such as refrigerators, ranges, and air conditioners, often require dedicated circuits. The code specifies the minimum ampacity for these circuits, as well as the type of wiring required. When calculating the load for a manufactured home, Article 550.18 provides specific guidelines. The total load must be calculated to ensure that the service and feeder conductors are adequately sized. Demand factors are permitted for certain loads, which can reduce the overall size of the service. The service equipment for a manufactured home is covered in Article 550.21. The service equipment must be readily accessible and located in a safe place. The service disconnecting means must be capable of disconnecting all ungrounded conductors. Article 550.23 outlines the requirements for feeders. Feeders are the conductors that run from the service equipment to the distribution panel within the manufactured home. The feeder conductors must be sized to carry the calculated load. The National Manufactured Home Construction and Safety Standards, often referred to as the HUD code, also plays a significant role in the construction of manufactured homes. Although the NMHBA itself does not have a separate electrical code, the HUD code references the NEC and incorporates many of its provisions. The HUD code addresses various aspects of manufactured home construction, including electrical systems, plumbing systems, and structural requirements. It is essential to comply with the HUD code when building or installing a manufactured home. In addition to the NEC and the HUD code, local building codes may also apply. Local codes can vary depending on the jurisdiction, and they may impose additional requirements beyond those specified in the NEC. It is important to check with the local building department to determine which codes apply to the specific project. When working on electrical systems in manufactured homes, it is crucial to follow all applicable codes and standards. Electrical work can be dangerous, and it is important to take precautions to prevent electrical shock and fire hazards. Always disconnect power before working on electrical circuits, and use appropriate safety equipment, such as insulated tools and gloves. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician. An electrician can ensure that the electrical work is done safely and in compliance with all applicable codes. Finally, remember that electrical codes are constantly evolving. It is important to stay up to date on the latest changes to the NEC and other applicable codes. This can be accomplished by attending training courses, reading industry publications, and consulting with electrical inspectors. By staying informed, you can ensure that your electrical work is always safe and compliant. Considering the specific context of building a cabin structure at a state park, it is crucial to understand the implications of using mobile home electrical standards. While Chapter 55 provides a solid foundation, the unique environment and usage patterns of a cabin may necessitate additional considerations. Cabins often have different occupancy patterns than typical mobile homes. They might be used seasonally or as occasional vacation rentals, leading to periods of inactivity. This can affect the types of electrical loads and the potential for issues like moisture buildup or pest intrusion. Therefore, it's important to select electrical components and wiring methods that are suitable for these conditions. For example, using corrosion-resistant materials in damp environments and ensuring proper sealing of electrical boxes can help prevent problems down the line. Cabins located in state parks may have specific requirements related to energy efficiency and environmental impact. Some parks may encourage or even mandate the use of renewable energy sources like solar panels or wind turbines. Integrating these technologies into the electrical system requires careful planning and coordination with the utility provider. The electrical plans must account for the additional equipment, wiring, and safety measures associated with renewable energy systems. State parks may also have restrictions on the types of lighting fixtures and appliances that can be used in cabins. For example, they might prohibit the use of incandescent light bulbs in favor of more energy-efficient LED lighting. Similarly, they might have requirements for water heaters, refrigerators, and other appliances to meet certain energy efficiency standards. The electrical plans must reflect these restrictions and ensure that all equipment complies with the park's regulations. Cabins often have unique architectural features that can affect the electrical system. For example, they might have vaulted ceilings, exposed beams, or unconventional wall construction. These features can make it challenging to run wiring and install electrical boxes. The electrical plans must take these architectural elements into account and propose wiring methods that are both safe and aesthetically pleasing. Cabins located in remote areas may be subject to more frequent power outages than typical mobile homes. This can be a significant inconvenience, especially during peak seasons when the cabin is fully occupied. To mitigate the impact of power outages, it may be necessary to install a backup power system, such as a generator or battery system. The electrical plans must include provisions for connecting a backup power system and ensuring that it is properly integrated with the main electrical system. Given the potential for varying environmental conditions and usage patterns, it is advisable to conduct a thorough site assessment before finalizing the electrical plans. This assessment should consider factors such as climate, soil conditions, exposure to sunlight, and the availability of utilities. The findings of the site assessment can help inform the selection of electrical equipment, wiring methods, and safety measures. Collaboration with other professionals, such as architects, engineers, and contractors, is essential to ensure that the electrical plans are properly coordinated with other aspects of the cabin project. Regular communication and information sharing can help prevent conflicts and ensure that the final product meets all applicable codes and standards. The electrical plan should be clear, concise, and easy to understand. They should include detailed diagrams, specifications, and instructions for installation. The plan should also identify any potential hazards or challenges and provide recommendations for mitigating them. Before submitting the electrical plans for approval, it is advisable to have them reviewed by a qualified electrical inspector or engineer. This review can help identify any errors or omissions and ensure that the plans comply with all applicable codes and standards. Once the electrical plans have been approved, it is important to follow them carefully during the installation process. Any deviations from the plan should be approved by the electrical inspector or engineer before they are implemented. After the electrical system has been installed, it should be thoroughly tested and inspected to ensure that it is safe and functioning properly. Any deficiencies should be corrected before the cabin is put into service. Regular maintenance and inspections are essential to ensure that the electrical system continues to operate safely and efficiently. This includes checking wiring connections, testing GFCI receptacles, and inspecting the grounding system. By taking these steps, you can help ensure that the electrical system in the cabin is safe, reliable, and compliant with all applicable codes and standards. This will provide peace of mind and ensure that the cabin is a comfortable and enjoyable place to stay. Remember that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest changes and to consult with qualified professionals when necessary. This will help ensure that the electrical system in the cabin remains safe and compliant for years to come. It is also essential to document all electrical work that is performed in the cabin. This documentation should include the electrical plans, permits, inspection reports, and any other relevant information. This documentation can be valuable for future reference and can help facilitate any future electrical work that may be required. Before commencing any electrical work, it is essential to obtain all necessary permits from the local building department. The permit process ensures that the electrical work is performed in compliance with applicable codes and standards. The permit also provides for inspections by qualified electrical inspectors to ensure that the work is done safely and correctly. When selecting electrical equipment and materials for the cabin, it is important to choose products that are listed and labeled by a recognized testing laboratory such as UL or ETL. This ensures that the products have been tested and certified to meet safety standards. Using listed and labeled products can help prevent electrical hazards and ensure the safety of the cabin occupant. It is also important to consider the environmental impact of the electrical system. Choose energy-efficient appliances and lighting fixtures to reduce energy consumption and minimize the cabin's carbon footprint. Consider using renewable energy sources, such as solar panels, to further reduce the cabin's environmental impact. When running wiring in the cabin, it is important to follow best practices for wire management. Keep wires organized and neatly bundled together. Use appropriate wire connectors and terminals to ensure secure and reliable connections. Protect wires from physical damage by routing them through conduit or other protective enclosures. It is also important to properly label all electrical circuits. This will make it easier to identify and troubleshoot circuits in the future. Use a circuit directory to document the function of each circuit breaker or fuse. This directory should be located near the electrical panel and should be updated whenever changes are made to the electrical system. When working on electrical circuits, always disconnect the power before commencing any work. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. This will help prevent electrical shock and injury. It is also important to wear appropriate personal protective equipment, such as insulated gloves and safety glasses, when working on electrical circuits. This will provide additional protection against electrical hazards. If you are not comfortable working on electrical circuits, it is best to hire a qualified electrician. An electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. Hiring an electrician can help ensure that the electrical system in the cabin is safe, reliable, and compliant with all applicable codes and standards. Remember that electricity can be dangerous. Always take precautions to prevent electrical shock and fire hazards. By following these guidelines and working with qualified professionals, you can help ensure that the electrical system in the cabin is safe, reliable, and enjoyable for many years to come. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer before commencing any electrical work.